Hello everyone, this is a lecture about trigonometry. Basically the first lecture in a series of lectures, and we start with introducing a new unit of measurement for measuring angles. In mathematics or even in science, there are many quantities such as distance, for example, which are measured with particular units. Some of the units of measurement for distance are centimeters, kilometers, millimeters, meters, or we have imperial units such as inch and feet and yard, and so on and so forth. In order to measure time as another quantity, we have lots of units of measurement such as seconds, minutes, hours, days, weeks, milliseconds, nanoseconds, and so on and so forth. So in order to measure angles, we are using three units of measurement, two of which are more important than the other one. So one is degrees, which you have always used it, even in elementary school. You used to talk about talk about right angles whose measures were 90 degrees. The second unit of measurement we want to talk about is called radians, which is roughly about 57 degrees, and it's a bigger unit of measurement, just like kilometers is a bigger unit of measurement compared to meters. So radian is a unit of measurement for measuring angles, but it's bigger than 1 degree. As you know, 1 degree is 1 over 360th of the circumference of a circle. So if you divide the circumference of a circle into 360 equal parts, then the measure of each central angle would be 1 degree. Now, if you divide the circumference into 400 equal parts, then the measure of each central angle is called 1 radian. And we don't use that much in our literature, but it is a unit of measurement out there. So our focus is radian right now. So we consider a circle here whose radiuses are units, and that could be like 10 centimeters, for example. And we have this central angle here, okay? And we are defining 1 radian as the measure of a central angle, okay, such that it is subtended by an arc equal to the radius of the same circle. So if the radius of the circle is 10 centimeters, we have 10, 10 right there. Now the arc length that is opposite this central angle, I know it's a curved line, it's not a straight line, it's not like a line segment, it's a curved line, we call it an arc length. But that arc length, end of the day, has a length, and that length is supposed to be equal to the length of the radius, whatever it may be. If that happens, then the measure of this central angle, which roughly is about 57 degrees, as I said, is called 1 radian. So 1 radian, the symbol is RAD. 1 radian is the measure of a central angle that is subtended by an arc whose measure is equal to the radius of the circle. Now, I wonder if we have a central angle whose measure is a little bit more than 1 radian, okay? So if point A and B are two endpoints of this arc length, and if point B starts moving along the circle and it moves a little bit forward such that the arc length is twice the size of the radius, so if the radius was 10 centimeters, now this arc length may be 20 centimeters. If that happens, what do you think the measure of the central angle will be in radians this time? You're going to say, well, if the arc length was 10 centimeters, the measure of the central angle was 1 radian. Now that is 20 centimeters, well, it's going to be twice the size. That is 2 radians, and you are right if you think so. So that is 2 radian. 2 radian would be the measure of a central angle that is subtended by an arc twice the size of the radius. Now, what happens if point B continues its journey, and when it started moving along the circular pathway of the circle, along point B, what if it continues moving even further, such that the arc length is 3 times r? I mean 30 centimeters, for example. The radius is 10, so we have like 10 centimeters, 10 centimeters, and the arc length is 30 centimeters. So that's 3 times the size of the radius. If that happens, what do you think the measure of this central angle will be? I know you're saying it will be 3 radian, and you're absolutely right. So if this trend continues and point B keeps moving forward on this circular path, and then we have an arc length whose measures like 4r and then 5r, so on and so forth, well, we are generating angles, central angles whose measures are 4 radian, 5 radian, 6 radian, just like that, okay? Now I wonder what happens if this point B continues its journey and after making one full revolution stops at point A itself. So in that case, I wonder what is this arc length that is actually equal to the circumference of the circle. So I would say the circumference of the circle is actually 2 pi r. So we have an angle in the middle. It's our so-called central angle, but we call it a perigon in this case. And that central angle is subtended by an arc which is not like 3r in length or 2r in length, but instead it is 2 pi r actually, circumference of the circle. In that case, what will be the measure of the central angle? You're going to say, well, if the arc length was 2r, the measure of the central angle was 2 radian. If the arc length was 3r, the measure of the angle was 3 radian. So 4r, 4 radian, 2 pi r, 2 pi radian, logically speaking. So the measure of the central angle is actually going to be 2 pi radian. Okay, but everybody knows that circumference of a circle, or not circumference, but one full revolution around any circle is 360 degrees, right? So I may write down here 360 degrees equals 2 pi radian, okay? So that's one conclusion we come up with. And from this statement, that we just derived, we can come up with other statements such as 180 degrees equals pi radian. Okay, pi radian is 180 degrees, and pi is 3.14, correct to 2 decimal places, And then you can say 90 degrees, which is half of that, would be pi over 2 radian. And then we have 60 degrees, which is 1/3 of 180, right? So it would be 1/3 or pi over 3 radian. And then we can have 45 degrees, which would be pi over 4 radian. And then 30 degrees, which would be pi over 6 radian. And the list goes on and on and on. But what we need to remember is perhaps this line here. And it says that pi radian equals 180 degrees. Many high school students, by mistake, when you ask them what is pi, they tell you 180. And then when you show them on the screen of a calculator, actually I have one here, on the screen of the calculator, you show them that pi is actually, I don't know if you can see it or not, but it's 3.141592654, and then they start scratching their heads. They're saying that their teacher said that pi is 180. So they misunderstood actually the fact that the teacher never ever said pi is 180. And that's not what we are saying here. What we are saying here is that pi radian is equal to 180 degrees. Let me give you an example. In elementary school, you learned that one of the units of measurement for mass is kilograms. So 1 kilogram equals 1,000 grams. A gram is a small unit of measurement for measuring mass. So when we are saying 1 kilogram equals 1,000 grams, it doesn't mean that we are saying 1 equals 1,000. But what we are saying is that 1 kilogram equals 1,000 grams. So it's the same thing when we are saying 180 degrees equals pi radian. It doesn't mean that 180 equals pi. Obviously, pi is 3.14. It has been like this for like centuries, I should say. So nobody says that 3.14 equals 180 in the same way that nobody was saying 1 equals 1,000. But what we're saying is that 3.14 radian is equal to 180 degrees. That's what we're saying. So you have to be very careful about this misconception. Now, when we're using this terminology, maybe we quickly mention that pi is 180, but that's not what we mean. Well, even if somebody says pi is 180, that's not what they mean. They mean pi radian is 180 degrees. Okay, I'm glad that I mentioned about this clarification. Um, and now the question is, how do you convert from degrees into radian and so on and so forth? Um, Let me just quickly also mention about this story of degree. Already I mentioned it, but I mention it one more time. So if you have a circle, okay, and you divide the circumference of the circle into 360 equal parts, and you grab one of those uh, little parts, the measure of that central angle, okay, the measure of this little angle is 1 degree, which is 1 over 360th of the circumference. The measure of that angle, the central angle, is 1 degrees because it is subtended by an arc which is 1 over 360th of the circumference of the circle, because we divided the circumference of the circle into 360 equal parts. And if you divide into 400 equal parts, each angle would have a measure of 1 gradient, as we said. So that would be a little bit smaller than 1 degree. But we don't talk about that other one, other unit. Okay, so in order to convert units, one way of doing it is by using this nice formula, d over 180 equals r over pi. D stands for the degree measure of the angle, and R stands for radian measure of the angle. Okay, so R is the radian measure, and D stands for degree measure of the angle. So let me give you an example. 135 degrees. Okay, we want to convert it into a radian. 135 degrees. How many radian? So you're going to plug in for D, because D is given 135 degrees. That's the degree measure of the angle. So now we can do a cross multiplication. So 135 pi equals 180r, and from there 135 pi over 180, which of course you can reduce the fraction. You must. It's going to be 3 pi over 4 radian. Therefore, we say 135 degrees equals 3 pi over 4 radian. That's the conclusion. Now, if it's the other way, if radian is given, you want to convert it into degrees, well, you plug in for r and you solve for d. Very simple. So let's say you have 7 pi over 6 radian, and we want to know how many degrees equals 7 pi over 6 radian. So you plug in for r, do the cross multiplication. So pi d equals 180, 7 pi over 6, pi and pi cancel each other. So we end up with 210 degrees after you do the math. Therefore, 7 pi over 6 radian equals 210 degrees. Now, sometimes we write RAD, sometimes we don't even write anything. Okay, that's the custom, you know. But for degrees, you have to put that little circle at the top right corner, which is the symbol for degrees. Okay, so 7 pi over 6 radian is equal to 210 degrees, and 135 degrees equals 3 pi over 4 radian. Okay, you don't need to plug in 3.14 for pi, although you could. If you want to approximate the measure of the angle in radian, you can plug in 3.14, multiply by 3. It's going to be like about 10. 10 divided by 4, roughly like 2.5. So this is like 2.5 radian, roughly speaking, you know. But you don't have to. You leave it in exact value by default. So this is one way of conversion using the formula. Another way is by using this unit conversion instruction to convert from radian to degrees multiplied by 180 over pi, but to convert from degrees to radian, this time multiplied by pi over 180. So these are fractions. We call them unit conversion factors. You can multiply different angles in a radian per degree by these factors and convert them. That's a second way of doing the conversion. Let's say you have 2 pi over 3, okay? 2 pi over 3 radian, right? So it says to convert from radian to degrees, we multiply by 180 over pi. So I'm going to grab the radian angle multiplied by 180 over pi. Pi and pi cancel each other. I end up with 120 degrees. There you go. So that's another way of converting angles from radian to degrees back and forth. Or for example, if you have something like let's say 150 degrees. So to convert from degrees to radian, multiply by pi over 180. So I just multiply this by pi over 180, and 0, 0 cancel out each other. We get 15 pi over 18, and then you have to reduce. So it's going to be 5 pi over 6, I believe, right? So 5 pi over 6 radian equals 150 degrees. So this is another way of converting the units. And that was another way. And another way would be by discretely plugging in 180 for pi. So let's say you have something like, let's say you have 3 pi over 8, okay? So discretely, without telling anybody, you're going to say 3 times 180 over 8. I extensively talked about the fact that pi is not 180, but here we know what we're talking about. Pi radian is 180 degrees. So instead of pi, you can just quickly plug in 180 and then just reduce the fraction, see what the answer is. So I think that will be 90 over 4, which is 45 over 2. That's 22.5. And that's going to be 67.5 degrees. 22.5 times 3. That's going to be, yes, 67. 22.5 times 3. Yeah, 67.5 degrees. Okay, so that's just another quick way of converting. If you want to know what is the measure of an angle in degrees, instead of pi, quickly plug in 180, for example. Okay, one more thing here. There is an arc length formula. Arc length is shown with letter A or S, and arc length is defined as the radius of the circle times the measure of the angle in radian. So A equals r theta. A is the arc length, r is the radius, and theta is the measure of the central angle in radian. So if you have a sector, we call this a sector, which looks like a slice of a pizza, and you want to find the arc length, well, you're going to say A equals r theta. We are using the formula. And this theta, I put RAD as a subscript on purpose to remind you that it has to be in radian. So when you multiply 12 centimeters, which is the radius of the circle, by the measure of the angle, if you put 45, that would be completely wrong because 45 is in degrees. So you have to convert that degrees into radian first by multiplying by pi over 180. So it becomes 45 pi over 180. So now the measure of the angle is in radian, as it is supposed to be, like in the formula. And now you're going to say, okay, so that's going to be 12 pi over 4, which is 3 pi. So the answer to the arc length is 3 pi centimeters. Okay, centimeters. Now, if you want to find the approximate answer, you're going to plug in 3.14 for 3, and then whatever the answer is, that will be approximate answer. So we can just do the math. 3 times 3.14, it would be 9.42. So 9.42 centimeters. So this means that the arc length that is subtended by a 45-degree angle in a circle whose radius is 12 centimeters is about 9.42 centimeters. Now remember, if you would multiply 45 by mistake without converting into radian and multiply 45 by 12, you would end up with a huge answer that would be like totally unreasonable. Okay? Yeah, for now this much, and we're going to talk more later. Thank you.